Today, I'm going to teach you about relationship between zeros and coefficients of a quadratic polynomial. What exactly is a zero of a polynomial? Any real value, any real number a is called the zero of a polynomial. Let's say we have a polynomial p of x if p of a equals to 0. Let we have a polynomial 2x plus 3. Now, if I put this x as minus 3 by 2, so let's substitute the value of x as minus 3 by 2. So what will it change? You put it like this. You cancel this 2 minus 3 plus 3 is now what? It's 0. So p of minus 3 by 2 is 0 over here. So this is called the 0 of my polynomial, p of x. So I'll say minus 3 by 2 is 0 of polynomial 2x plus 3. That's called the 0 of a polynomial. Now let's discuss what a quadratic polynomial is. So a quadratic polynomial, as you all know, is of degree 2. Quadratic polynomial is a polynomial with degree 2. Now, what is this degree 2? Let's say you have a polynomial written as 2x square plus 3x plus 5 equals to 0. Let us say we have this as a polynomial. Now over here, the degree of the variable, the highest degree, not the degree, highest power of variable is 2. Here, x square, this is x raised per 1, here x raised per 0. So highest power of the variable is 2. So we say that this degree is 2 over here. So quadratic polynomial is a polynomial with degree 2. Now, a quadratic polynomial also has a standard form. So what is the standard form for the quadratic polynomial? So standard form of a quadratic polynomial is written as ax square plus bx plus c. A is the coefficient of x. In the previous example, if I say what is the coefficient of x square? Sorry, a is the coefficient of x square over here. So what is the coefficient of x square here? So we can say that in the previous problem, a equals to 2. Now let's move on to b. B is the coefficient of x. What is the coefficient of x over there? So b is 3. Then c is the constant term. C is the constant term. So what is c over here? That is 5. Let us consider one more example. If I say I have 1 by 4x square plus 2x minus 7 equals to 0. So here what is a? A is 1 by 4. What is b? It's 2. What is c? That's minus 7. So that negative sign also comes with that because standard form is having all positive signs. So I hope this coefficient part is clear. Now let us move on. What exactly is the relationship between these zeros and the coefficient? Zero, I said. Now the problem that we discussed to find the zero was a linear polynomial, but in a quadratic polynomial, as the degree is 2, so zeros will also be how many? It will be 2. So in a quadratic polynomial, number of zeros is 2. See how these number of zeros are 2. In your ninth grade, in your 8th grade, you have learned how to factorize a quadratic polynomial. You people have learned how to factorize a quadratic polynomial by middle term splitting. Let us do the same thing here. Let's take a polynomial. Let's say we have 7x square plus 7x plus 10. I have a polynomial p of x is this. Now let's find the zeros of this. Find zeros of this polynomial. using middle term split. So how do you find middle term split? You know 10 and coefficient of x square is 1. So 10 into 1, 10. Factors of 10 are 2 and 5. And when you add 2 and 5, you get 7. So I can write this as, instead of 7x, I'll split it. It will become 2x plus 5x plus 10. From these two, I can take x common, x plus 2 plus 5 common from these two. So x plus 2. X plus 2 common, so it's left inside x plus 5. Now we have done middle term splitting of this polynomial. So how to find the zeros of this polynomial with this? So I'll say that either this is 0 or I can say this is 0. So I'll get x as minus 2, x as minus 5. These are the two zeros of this quadratic polynomial. These are the two zeros of this quadratic polynomial. Now I have found the zeros. Now from this polynomial only, I know what are the coefficients of x square, x and the constant term. What is a over here? A over here is, let me write it over here only. A was 1 because coefficient of x square was 1 only. Let me go back again so that we can see the polynomial. Now b. B was what? 7 and c is 10, the constant term. That is done. Now let's move on to another thing. The zeros I have. What is the relationship between these zeros? Let's find it out. And these coefficients. If I add these zeros, what is, let's say, sum of zeros? What is the sum of these zeros? Minus 2 plus minus 5 coming out to be minus 7. What is the product of these zeros? Minus 2 into minus 5, which is coming out to be as 10. If you see, is there any relationship over here? 7 and 10. Yeah, there is some relationship. So I will say the sum of the zeros is given by minus b by a in terms of coefficients. Product of the zero is given by c by a. So let the zeros be alpha and beta. Let zeros of any polynomial, it has to be a quadratic only because I'm talking only about two zeros. So they are alpha and beta. So alpha plus beta is given by minus b by a, and alpha beta is given by c by a. The product and the sum. Alpha plus beta, alpha beta. Clear? And we verified it also. How you verify over here? You have got this thing. So sum was minus 7 I got. B value was 7. So minus 7 by 1. So minus 7 equals to minus 7. Same case over here. Product was 10. C's values was 10 only. 10 by 1 is 10. So you verified it also. Till here, I think it's clear. What we found out is we found out the zeros of the polynomial. Then we compare that the zeros, how these zeros are related to the coefficients. So we found the sum of the zeros, we found the product of the zeros. Now let's move to few more examples. Let us say I have a polynomial 6x square minus 3 minus 7x. This is example number 2. So here, let's first arrange it like this. Now I can say A is 6, B is minus 7, C is minus 3. What is alpha plus beta? I know is minus B by A. Alpha beta is, I know, is C by A. But I need to get alpha and beta. There is no alpha beta over here. So I will have to do what? Middle term split over here. So let's do it. So the polynomial is 6x square minus 7x minus 3. Product of 6 and 3, 18. Factors of 18 is also 6 and 3, but 6 and 3 you cannot get 7. So let's take other factors. 2 into 9. 9 minus 2 will give you 7, but it is minus 7, so I have to do minus 9x plus 2x to get minus over here. Minus 7. So from these two I can take 3x common, so it's 2x minus 3. From here I'll take only 1 common to get 2x minus 3. Again 2x minus 3 common, so what is left? 3x plus 1. To get the zeros from this, what do we have to do? 2x minus 3 is 0 or 3x plus 1 is 0. So x is over here 3 by 2 because 3 goes here, 0 plus 3 is 3 by 2. And over here it is x is equals to minus 1 by 3. Now let's find out. I have the zeros, the sum of the zeros. I know sum of the zeros is equals to minus b by a. But here what are the zeros? 3 by 2 plus minus 1 by 2, 3. Beta and alpha I got. Now in a polynomial over it is here. Fine. Negative of minus 7 by 6. Let's see, it's coming same. LCM is 6 over here. You'll multiply it by 3 and 3. So that's 9 minus, you'll multiply it by 2 over here. So minus 2. This is 7 by 6. This is also 7 by 6. So this is verified. Now let's take product of zeros. Product of zeros I know is c by a. Product will be 3 by 2 into minus 1 by 3. So 3 cancels out. C is minus 3 by 6. So you'll get it as minus 1 by 2, also minus 1 by 2. Hence verified. So this is the relationship between zeros and coefficients of the variables. Now let's take some complicated problems which generally comes in board related to this topic. So let's start with few of the problems. Let's say if, let's take a question which have been asked in 2019 in boards. If alpha and beta are the zeros of the polynomial fx is equals to x square minus 4x plus 3, find the value of alpha 4 beta square plus alpha square beta 4. So how are we going to find out this? Alpha beta are given as the zeros of the polynomial. I need to just find out this. Now from this, if you see what is given to you, let's first take fx, which is x square minus 4x plus 3. What is the coefficient of x square? 1. So a is 1, b is minus 4, and the c is 3 over here. Now from here, another thing, we have to find out this thing. Okay. From this, can I take anything common over here? I can take alpha square common, I can take beta square common. When I take alpha square, beta square common, what left inside is alpha square from this side and beta square from this side. I can solve it very well because this I know is alpha beta whole square. Here it is alpha square plus beta square. How will I solve it? Now let me tell you all one thing about it. If you remember identities that you people did in 8th grade, 9th grade, so you are going to use that over here. You all know what is a plus b whole square. A plus b whole square is given by a square plus b square plus 2ab. From this you can say same thing. If I say it as alpha plus beta whole square is equals to what? Alpha square plus beta square plus 2 alpha beta. Now from this, what is the value of this alpha square plus beta square? So alpha square plus beta square is nothing but, you just take it over here, alpha plus beta whole square minus 2 alpha beta. So this is what I'm going to use over here. Now you see what you need is only, you don't have to find zeros, you just have to find what is alpha beta, what is alpha plus beta. So let's find out what is alpha plus beta. Alpha plus beta is minus b by a. So minus 4 by 1, which is 4. What is alpha beta? That will be c by a, which is 3 by 1. So that's 3. I have these things. Now let's put it over here, both the things. So alpha beta whole square, alpha square plus beta square will change to 3 square, and alpha square plus beta square is what? It's alpha plus beta whole square minus 2 alpha beta. I hope it's clear how we get it. You need to remember it because it's being asked in many problems. So 3 square is 9, alpha plus beta is 4 square, minus 2 alpha beta is 2 into 3. So that's 9 into 16 minus 6, which is 9 into 10, 90. So this is how we solve the question. I hope there is no problem. Let's just repeat how I did it. I'll just explain once more the same problem. The polynomial was given as x square minus 4x plus 3. I need to find out the value of this thing. So what I did is, from this I took common alpha square beta square and changes into this form, alpha square beta square into alpha square plus beta square. And from the given polynomial I know a is 1, b is minus 4, c is 3. Now from here I have just explained how I'll get the value of alpha square plus beta square from this identity, which is this thing, alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta. Now alpha plus beta, sum of zeros is minus b by a, which is 4, alpha beta is c by a, so 3 by 1 is 3. Then I just have to substitute all these values over here and calculate it. So alpha beta was 3, so 3 square 9, alpha plus beta was 4, so 4 square, minus 2 into 3 6, so that's 9 into 10 90. I hope it is clear. Let us take one more problem of this type. If alpha and beta are the zeros of the polynomial px is given as 2x square plus 5x plus k, satisfying the relation alpha square plus beta square plus alpha beta is equals to 21 by 4, then find the value of k. I need to find out the value of k. So let's simplify this question. Here again, this relation is given, and from this relation we know we can change it. I explained in the previous problem. Let's start. So polynomial is given as 2x square plus 5x plus k. So a is 2, b is 5, and c is k. From here I can say alpha plus beta is minus b by a, which is minus 5 by 2. Alpha beta is c by a, which is k by 2. Now what is given to me, that alpha square plus beta square plus alpha beta is 21 by 4. Let's put all the values. Alpha square plus beta square I know is what? Alpha plus beta whole square minus 2 alpha beta plus alpha beta is 21 by 4. I can simplify it further. Alpha plus beta whole square minus 2 alpha beta plus 2 alpha beta is minus alpha beta. What is the value of alpha plus beta? Minus 5 by 2 whole square minus k by 2 is 21 by 4. Let's simplify this and we are done. So it will be 25 by 4 minus k by 2 is 21 by 4. Variables take on the other side. 25 by 4 minus 21 by 4 is equals to k by 2. So what I'm getting over here, 21 minus 25 minus 21 is 4 by 4 into 2 is k. So k is 2. Got your answer? This is what we were supposed to do in this. So I hope this verification of coefficient and how to solve for all these things is clear in this video. So over here we just solved. The new thing that you learned, one is this, how to get this value of alpha square plus beta square. So keep practicing questions like this. You will understand it more properly. So I'll come up with more videos in which we'll do more problems. So thanks